That is incredible. The Juno probe mission is coming to an end, but its ending is not a return home. Instead, it will plunge into Jupiter's atmosphere and be completely incinerated there, but no one expected that in the final stage of its life, it would actually capture an image. An image that could potentially rewrite everything we know about Jupiter. It was supposed to be just an ordinary flyby mission. After the images were sent back to Earth, the scientists took their first look. At first glance, they saw nothing unusual, a vast cyclonic system, just like before, with a stormy, rotating core at the center, until they switched this image to the infrared and microwave bands, and it was truly shocking that central storm, under infrared, actually completely disappeared. No heat, no structure, not even any depth. It was as if someone had painted a fake storm on the clouds. It looks very active, but there is no energy supporting it. It is spinning, there is no heartbeat. This is not just strange. It is downright counterintuitive. It directly challenges our understanding of the physics of giant atmospheres. In previous theories, storms like this should have been full of internal convection, heat sources, and vortices. The structures are layered one on top of another, but this image seems to say, "You have not understood anything." At one point, scientists thought it was an instrument, but after repeated comparisons, it was not a malfunction. It was an atmospheric phenomenon never seen before. Some speculate it is an ultra-shallow vortex. It is sustained by a mechanism we have yet to understand, but for now, no one knows the truth, and this is only the first mystery Juno has left us. Over the next 9 years, it witnessed the most powerful volcanic eruptions in the solar system, recorded the first collision between storms, and even on the surface of Jupiter's moons, discovered strange patterns never before seen by humans. As the Juno mission is coming to an end, before it departs, let us follow its gaze, and journey once more through Jupiter's clouds, to see how many mysteries still lie behind this planet waiting to be unlocked. Journey to Jupiter is more than just interstellar travel. It is a 9-year space campaign spanning 2.6 billion kilometers. On August 5, 2011, Juno launched from Earth, but it did not head straight for Jupiter. Instead, it first looped past Mars, then flew back toward Earth. Was this a malfunction? It was not a carefully planned gravity assist experiment. The engineers used Earth as a slingshot, using its gravity to fling Juno outwards, accelerating it to 26,000 kilometers per hour, breaking out of the inner solar system, heading straight for Jupiter. July 5, 2016. Juno finally arrived at Jupiter. It did not take a conventional orbit. Instead, it entered an extremely elongated elliptical orbit. Every 43 days, it passes over Jupiter's poles once. At its closest, it is only 2,400 kilometers above Jupiter's cloud tops. This is the first time a human probe has peeked at Jupiter from such a close and unique angle. It is precisely because of this orbital design that Juno is able to fully scan Jupiter's magnetic field, atmosphere, poles, and deep structure. Over these 9 years, it has not only witnessed the massive volcanic eruptions on Jupiter's moon No, it also recorded the first collision between storms. It captured mysterious patterns on the satellite's surface, never seen before. But what truly overturned our understanding was a set of data sent back at the end of the mission. During the latest flyby, Juno sent back images and gravity readings that left even veteran scientists in collective silence. It turns out those colored bands we see are not just surface coatings. It is an atmospheric band 2,897 kilometers deep, yes, that is 270 times deeper than Earth's deepest ocean trench. This means Jupiter's atmosphere is not just clouds, it is a deep system with structure and energy cycles. There is no other planet like it in the entire solar system, and between these wind bands are those legendary storms that could swallow the entire Earth. It can tear apart a probe, but somehow has been spinning steadily for hundreds of years. Even more astonishing, during the close flyby on November 29, 2021, Juno skimmed right above Jupiter's clouds and captured a stunning photo. The image shows a bright dome of clouds floats above the storm. The moment the shadow is cast, it is as if the whole world gains three-dimensional depth. Those insignificant little white dots in the image, each one is actually as large as a city. This is humanity's first time facing Jupiter at such resolution. We discovered that the intersections of storms are not chaotic, but a higher order. They collide, spiral, and spin up cyclones hundreds of kilometers deep, forming a dizzying forest of swirling vortices, and those popping cloud masses shoot up into the sky like fountains, spanning 30 to 40 kilometers wide. Yet they are still just small ripples. This planet, with almost every detail, is telling us one thing: welcome to a world that truly does not follow Earth's rules. In fact, The real monster of scale is not in the movies. It is hanging on Jupiter, and it is called the Great Red Spot. This is a superstorm big enough to swallow Mercury and Mars. Its diameter is over 16,000 kilometers during its 7th orbital flyby. The Juno spacecraft skimmed right above it and captured its true appearance. That is no longer just a pattern in a textbook, a spinning monster that has truly existed on a planet for centuries. And it is not the only astonishing thing on Jupiter. Every time we fly around Jupiter, we uncover an even deeper layer of this planet's madness. For example, its south pole seems to be arranged by some kind of strange order. Seen from 50,000 kilometers above, several massive oval vortices steadily circle the center. Each one has a diameter of over 600 kilometers, like the eyes of giants watching over the entire planet. Juno's mission does not end there. Another key focus is closely observing Jupiter's group of little satellite brothers. The wildest among them is Io. This is a planet with a diameter similar to the Moon's. Yet it contains over 400 volcanoes. Volcanic plumes can shoot up as high as 300 kilometers. It is like fountains of lava bursting straight through the ceiling, with Jupiter's massive shadow as the backdrop. The horizon is constantly erupting with fire. This is not fantasy, it is reality captured by the Juno spacecraft. Why is Io so restless? Because it is subjected to cosmic level kneading every day. It forms a perfect gravitational resonance with Europa and Ganymede. Like three pendulums precisely aligned, pulling and tugging at each other, causes Io's orbit to be periodically squeezed and stretched. The result? The crust cracks, magma churns, and volcanic eruptions never cease. Juno flew by at an ultra-low altitude of just 2,400 kilometers. It captured 2 volcanic plumes erupting straight from the horizon. NASA even used these images to reconstruct one of the volcanoes, Vashtar. That is not a volcano. It is a planet-sized geyser. The lava shot up 330 kilometers high. It is beyond anything we know on Earth, but Io's madness does not stop there. In 2023, Juno captured new images of Io's South Zal region, compared to Galileo's photos from 24 years ago. The entire mountain has split open. Lava is flowing out. It is not a geological relic, but a living planet that is deconstructing itself. The infrared spectrometer Jerem recorded everything. Scientists created the first volcanic heat map of Io. Each bright spot is an erupting volcanic crater. The most astonishing is a volcanic depression called Loki Patera. Its volcanic depression 1000 to 1000 giga-oct. The most astonishing is a volcanic depression called Loki Patera. It has a diameter of 200 kilometers. It is even larger than the crater that wiped out the dinosaurs. The entire volcanic lake is covered by a thin crust. Islands are scattered across it. Hot currents churn beneath. Yet its surface is smooth as a mirror, like a giant glass lake in hell. This is not an exaggeration, it is exactly how scientists described it. Torn between fire and ice, it displays a morbid perfection. But what is even more bizarre is yet to come. Juno also discovered a strange mountain called Spire Mountain after 2 close flybys. Its true appearance was revealed like a Gothic cathedral carved from volcanic rock, piercing through Io's chaotic surface. It stands 7.2 kilometers tall. If you jumped from the summit, under Io's weak gravity, you would fall for nearly 90 seconds. On Earth, this would be called a disaster. No, it is called scenery. Io might be the most fascinating moon to study in the entire solar system. Not because it is beautiful, but because it is wild. It is like a natural laboratory left by the universe for scientists, with its own crust, gravity, and volcanoes. It lays out planetary physics in plain sight. For decades, our understanding of it has relied entirely on simulations and speculation. It all only started to feel real when Juno got close. It was not just a coincidence. It was thanks to 2 instruments originally meant for something else. One is the microwave radiometer Immerse for studying Jupiter's atmosphere, and the other is the Jerem infrared spectrometer. Neither was designed for Io. Engineers forced these 2 eyes to focus on its crust. It is like using a medical scanner to examine a planet's bones and blood vessels. The results were astonishing. Beneath Io's crust, there is still flowing magma. About 10% beneath the surface is a region of slowly cooling lava. In other words, Io is like a planet-sized engine, with its outer shell constantly renewing itself, and beneath the lid, it is always boiling. Volcanoes, magma channels, thermal cycles. The whole planet is like a giant radiator that never stops. It constantly releases its internal heat into the universe, like a space racer billowing smoke in a vacuum. But that is not even the craziest part. In December 2024, Io experienced the largest recorded eruption in history. 3 whole months. The volcanic plume covered more than 65,000 square kilometers, that is equivalent to the entire country of Japan being submerged in lava. The energy released reached 140 to 260 terawatts. What does that mean? If you add up the total output of all the power plants on Earth, it would not even reach 1/10 of that. This is not just a geological event, it is a flood of planetary energy. NASA scientists are waiting for Juno's next flyby. It will once again approach this time it will get less than 80,000 kilometers away. It is like listening to a planet's heartbeat, to see if it will erupt with the fury of an entire crust once again. And echoing the heart of volcanoes, is another stunning discovery. Juno has brought us about Jupiter itself. We have long known that Jupiter's magnetic field is strong, but we did not know just how extreme it really is. Juno detected that in certain regions, Jupiter's magnetic field is more than 30 times stronger than Earth's. It is not just that a compass would shake the instruments on the probe itself, would trigger alarms. So where does its magnetic field come from? The answer is liquid metallic hydrogen inside Jupiter. This is a strange substance that only forms under extremely high pressure. It is both like a liquid. It is also like metal. Not only can it flow, it can also conduct electricity. It is precisely because of this liquid metallic core inside Jupiter that the strongest magnetic field system in the entire solar system is created. But Juno's mag instrument discovered a key detail. This metallic hydrogen is actually not buried deep in Jupiter's core. Its starting layer closer to the surface than we expected. This means we always thought Jupiter had a solid core with a clearly layered internal structure, but that might be completely wrong. It is not just a planet. It is like a giant, misunderstood reactor, hiding the flaws and arrogance in our definition of planets. Juno did not just confirm old theories. It completely shattered the data mysteries from 30 years ago. In 1995, the Galileo probe descended into Jupiter's atmosphere and found the upper layers unusually dry, with only 1/10 the expected amount of water. At the time, scientists thought it was just a coincidence. The probe might have fallen into a dry hotspot. But now we know that was not a coincidence. It was a hidden mechanism revealed by Juno in the same region. It discovered that in the equatorial zone, shallow lightning causes water and ammonia to combine into frost. These ice grains act like bombs, carrying water and ammonia into the deeper atmosphere, dries out the upper layer, leaving a misleading illusion. That mystery from 30 years ago was never misjudged. We just did not understand this planet well enough back then. That is why the most fascinating thing about science is not the answers, but the moments when we are proven wrong. And every approach by Juno, it keeps reminding us Jupiter is far more profound, hotter, and more unpredictable than we imagined. Although the Juno mission is nearing its end, it is still uncovering Jupiter's secrets. On April 29, 2025, NASA released new data about Jupiter's south pole, those immovable polar cyclones. This time, there are 8 atmospheric vortices surrounding the center in the image, arranged in perfect order, like a ceremonial array encircling some mysterious core. Each of them has a diameter of over 2,000 kilometers, roughly the distance from Beijing to Guangzhou. But these gigantic beings are surprisingly gentle. Unlike Earth's winds, they do not erupt, tear apart, or disintegrate. Instead, they persist for a long time, rotating steadily, almost as if they are chained cyclones anchored to Jupiter's poles. Scientists use Juno's Junocam and the infrared camera GIRUM to track how they slowly move around the central storm. Under the influence of beta drift, they slowly move toward the center, but between each other, they push away like compressed springs. They neither merge nor break apart. Instead, they form an almost eternal vortex ring. This kind of structure simply does not exist on Earth, but on Jupiter, it is the norm. For the first time, Juno has allowed us to truly see that on this giant planet, the weather is not chaotic, but follows a kind of order we have yet to understand. In September 2025, Juno will complete its 77th orbit and be guided to plunge into Jupiter's atmosphere, where it will burn up, fulfilling its final mission. 9 years, 77 orbits, countless adventures through storms. What it brought back was more than just photos and data. It also brought an ever-growing list of questions. Thought it would give us answers, but instead, it left us with even greater unknowns.